Hi, everyone. Thanks for joining. We will give folks a few more minutes to join and we will start momentarily. Thank you. Hi, everyone. Thanks for joining the webinar today. My name is Himanshu Chetri from AdTech, and we are here to go over the topic on best practices to achieve DevSecops. Before we get into the core content of the webinar, I just wanted to briefly introduce AdTech. So AdTech is a global professional services firm, and we have more than 13 years of experience in delivering software solutions for clients from all kinds of industry verticals. And we deal with organizations of different sizes, including mid-size and enterprise. We are also one of the top Atlasian solution partners in the US and APAC regions. In terms of office locations, our headquarters is in Princeton, New Jersey, and we have some additional offices in Los Angeles, in India, and Singapore. We have a wide variety of customers, pretty much spanning across all of the different industries and sectors, both in the the federal, state, as well as private space. The reason being that not only do we provide custom DevOps solutions, but also we are a software vendor. We publish apps in the Atlasian marketplace to extend the functionality of Atlasian tools like Jira Software and Confluence. Apart from Atlasian, we are also partnered with other major players in the DevOps and cloud space. Some key highlights being cloud service providers like Amazon Web Services, and in the DevOps space, we are partnered with organizations like JFrog, with Docker and Sonatype. And we also recently partnered with Monday.com. So we provide DevOps solutions, as well as we provide managed hosting. In terms of managed hosting, we specialize in helping our customers deploy their collaboration, SDLC, and DevOps tools, both on-premise as well as on the cloud. We also have a SaaS managed hosting offering called Code Factory, and then we also have an on-prem version of the same solution. And like I mentioned, we recently partnered with Monday.com, and our partnership both with Atlassian and Monday.com enables us to provide extensive implementation, training, and custom development solutions. So we also are experts in terms of providing training, both in terms of off-the-shelf solutions as well as training for any customized solutions that we help our customers build. We are not only software vendors in the Atlassian marketplace, but also we do custom development for our customers when they cannot find an off-the-shelf solution. And another expertise we have is migrations, which also ties to our managed hosting offering. We have done numerous migrations between on-prem and cloud hosting environments, or in the Atlassian ecosystem. We've also done a lot of migrations from server to data center, or server to cloud. So we have the capability to handle migration of any size, including enterprise. So briefly about myself, I'm an enterprise architect at AdTech, and I've been helping our customers at AdTech for more than 10 years across the full stack of services that we offer. So let's get into today's talk. And in terms of the agenda, we'll briefly look at the current market state in terms of application security and the kind of impact it's having. We will then look at how DevSecops can minimize some of the negative impacts that security and data breaches are causing. We will then look at our practical approach to remediate some of these issues by following DevSecops and application security best practices. And we'll focus more specifically on how our approach is to help customers improve their application security by performing a lot of checks and balances and scans as part of their CI/CD pipeline. And then we will also briefly touch upon a customer case study for a Fortune 500 customer. Also, before we proceed, I would encourage you to post questions in the Zoom Q&A section. And towards the end, when we have the Q&A section, I will address those. So I think a lot of us are very familiar with some of the headlines we hear about the data breaches, and these breaches span across all kinds of industries as well as the state and federal government bodies. And these data breaches can be very expensive, especially if you are part of a regulated industry. There can be huge fines imposed upon you if there are any breaches, as well as these also reduce customer confidence in your organization, which can also have a very lasting negative impact. So in terms of helping your organization prevent these data and security breaches, one of the best ways to prevent this is by practicing DevSecops. So DevSecops is a bit of a buzzword, and it is an extension of the ideas suggested by DevOps. But in terms of defining DevSecops, I really like the definition provided by Atlasian on their DevSecops tool page on their website, where they define DevSecops as the practice of integrating security into continuous integration, continuous delivery, and continuous deployment pipeline. And we'll dive deeper into how exactly you can integrate these practices as part of your CI/CD pipeline. So within DevSecops, if we look at the entire development lifecycle and software delivery process, you can visualize it as an infinite loop where you go from requirements to building out those requirements, shipping those requirements, and then using the feedback to repeat the process all over again. But if we more specifically divide this whole loop and iterative process into two parts, on the left-hand side, we have the pre-production part of the process where you would do your planning and you would write the code to satisfy the requirements. The code changes would trigger automated builds, and then you would perform your testing and QA. And usually you do all of these as part of the pre-production phase. And then in production, that's when you deploy the changes. Now, in terms of the security practices that you can implement, in the pre-production phase, you can run different types of application security scans for every code change. For example, you could run a static application security test anytime the developers change the code. You could also be running software component analysis or dynamic analysis as part of your software build process. And as part of your QA and testing process, you can also implement security tests apart from your core QA tests. So you could perform tests for attack vectors like SQL injection and cross-site scripting and so on. And then once you deploy the application, there are certain security checks that you can implement, like proactive log monitoring and alerts. There are also different mitigation techniques like implementing web application firewalls and so on. But in today's talk, we will talk about how we can influence and control a lot of things in the pre-production phase. So in order to understand how we can control things, especially early on during the development lifecycle, we also need to understand what is the cost of remediating security vulnerabilities when you discover them at different phases of your development and delivery lifecycle? The least ideal place to discover security vulnerabilities and remediating those would be once your application is either very close to production, or worse, your application has already been deployed to production. Once your application is in this late phase of your development lifecycle, this is the time when it's the most expensive when it comes to remediation. Your team may be dealing with a fewer number of vulnerabilities, but typically it can take teams anywhere from a few weeks to few months to remediate issues that they discover close to production, because now you have to schedule this as part of the next release. It could be an emergency release, or it could be part of your regular release cycle. And this can be very expensive and time consuming. You may also need to rerun all of your regression tests to make sure that your security fix itself doesn't fail some regression test that you may have. The other is a lot of teams tend to do some of these security checks during the QA process. And intuitively, this may seem like the right place to do a lot of these security checks, but even that can be too late, because typically it can take teams several days to weeks to remediate issues that they find during the QA process. The most favorable place to really discover and remediate these issues is during the development and commit lifecycle. The best place for developers, in fact, is right in their IDE. There are certain application security scanning tools that can perform checks like in the static application security checks, open source library and dependency checks, right within the developer's IDE or text or code editor. And the developers can get instant feedback as they're writing the code, and if they notice any severe security issues that could potentially be introduced by the code they're writing, they have the ability to remediate that then and there, rather than waiting, for the scans to happen somewhere, further down the development lifecycle. So in terms of application security scans, there is a growing variety of scans that can be done, and using different techniques and different tools. So like we said, during the coding phase, one of the most popular categories of checks are the static application security testing, or SAST, or also different kinds of code quality checks and open source library and dependency checks. These can typically run within the developer's IDE. Now, when we move on to the build phase, it is necessary to repeat the checks that the developers may be doing in their IDE, because you want to ensure that the developers haven't missed anything, even if they are running some of these checks and scans in their development environments and IDEs. And also the other thing is that as part of the build process, you can also run more variety of scans and checks that may not be feasible for the developers themselves to run. One example is checks like dynamic analysis, which involve deploying the application in a test environment and then running some live attacks like SQL injection or cross-site scripting. And then there are several other categories which are also increasing due to the complexity of the technology stack that the development team is dealing with. One example is that with the increase in popularity of open source Linux containers and container orchestration tools like Kubernetes, those also would typically require additional scan types like container scans. And all of these scans should ideally be run as part of the CI/CD tool, as part of the CI/CD pipeline, when it's automatically running the builds and automatically running the tests. And we'll look at why that's the ideal place to run all of these. And we will explain this in terms of a more practical example. So let's talk about an actual customer case study. So we recently helped a Fortune 500 bank implement a solution at their scale. And when we look at some of the problems they were facing, right, they were running these scans manually. They were not running these scans as part of the CI/CD lifecycle. And what that meant was that at their scale, where they have thousands of developers and thousands of software projects, um, it becomes extremely tedious to run scans manually. And then the other thing is not everything may get scanned, which is pretty scary because, as we know, banks and finance is one of the highly regulated categories of industries, and it is extremely important to make sure that every code change is compliant, including in terms of the application security health. So it was a constant, sort of cat and mouse game to make sure that teams were meeting the application security standards and they were doing a sufficient amount of scans, especially before they do a production release. But at their scale, there was a lack of awareness where, you had some teams that were savvy and they were implementing these scans, some including as part of the CI/CD pipeline, but the majority of projects were doing these scans in an ad hoc manner. And this introduced an unacceptable level of risk for this organization. The other is all of this inconsistent scanning also relates to inconsistent or incomplete reporting. Because even though this bank was using different types of application security scanning tools, uh, even for the limited number of scans, they had to go to all of these different tools to gather data on the application security health of different teams. There was no central location to look at all of the combined data from all of the scans happening from the various tools. And the other challenge was that the developers, they live within Jira software in terms of managing their development backlog and general project management. But all of these different scanning tools would require the developers to access the particular tools and their dashboards. And then there's a lot of context switch that the developers have to go through to gather all of the data across all of these different tools. And all of this also translates into a lot of unnecessary time being spent. And unnecessary time being spent in an organization for thousands of people also directly correlates to a lot of unnecessary costs. So this is extremely expensive for the organization. And also the application security team that had to support all of these application security scanning tools and had to chase these different dev teams to keep up with all of the scans. It was also very stressful for the application security team because they were relatively small compared to the thousands of developers they had to support. And it just wasn't possible to keep up with every team and all of the code changes that they were introducing. So in terms of our solution, so our solution had to be focused on the tools that the customer was already using for their development lifecycle. So like I mentioned, in terms of the developers, managing their backlog for their projects, they were using Jira software. In terms of version control and CI/CD pipeline, the customer was using GitLab. So GitLab allows users to version control their source code in Git repositories, and that's what the customer was doing. In terms of CI/CD pipeline, the customer was historically using Jenkins, but they had just started this new initiative to migrate start to migrate their projects towards GitLab, which provides a more robust CI/CD pipeline amongst other features. So we work with the customer to implement different types of application security checks and scans as part of the CI/CD pipeline. And if you implement this in using a more a naive approach, there are some major drawbacks because a lot of these application security scans can run for a very long time. It may take a few minutes, or in some extreme cases, it may take a few hours to finish running. And ideally, a CI/CD pipeline, should not run for a very long time, because the developers need constant feedback on their source code changes, where the build process needs to give them feedback. The automated tests that run in the pipeline needs to give them feedback. But some of these application security checks, they could take a long time to run, and the developers cannot just sit there waiting for these checks and scans to finish running. So our approach to running these scans was to run them in an asynchronous manner rather than in a synchronous or serial manner. So within the pipeline, within the GitLab pipeline for the different projects, we help the team implement a step in their process where they can invoke different types of scans, like the static scans and the dynamic scans and the open source dependency checks. And all of these run in parallel, as well as they run asynchronously, where the rest of the CI/CD pipeline would finish running without waiting for the scans to complete. So the question that you may have is, if these scans are running asynchronously, how exactly do you provide the results of these scans? And our approach to that was integrating these application security scanning tools with Jira software, where all of the results from the different scanning tools would automatically create Jira software issues in the development backlog for each of these projects. So the advantage of this approach was that the pipeline would finish running without taking too long, and if there are any significant findings, like critical or security blocker types of potential security issues, those would be automatically created as Jira issues and added into the backlog. So now the dev team doesn't need to perform a lot of context switching, because they can stay within GitLab and Jira software as their primary tools that they use on a day-to-day basis, and they can still get this continuous feedback from all of these different application security tools. And this worked out great, because this also freed up the application security team and some of the support they needed to provide, because now they could ask the teams to implement this framework as part of their CI/CD process. So there was a consistent way in terms of how these scans were happening. And this design really ensures that every code change gets scanned. There is no way to miss scanning any code change. Similar to how, once you implement CI/CD pipeline, it ensures that every code change gets built and the tests get run. And then if you have automated deployments, the automated deployments run. So similarly, you can extend that idea to application security checks and scans running for every code change. There's no way to miss those changes. And this provides a great feedback loop where the developers are constantly getting feedback very early on in their life cycle. If you had to extend this solution can work with any tool. It's not specific to GitLab or any specific application security scanning tools, because the whole idea is that with the help of our framework that we help customers implement, we can ensure that anytime the developers push code, the version control system would notify the CI/CD tool to run sort of the regular build, test, deploy phases of the pipeline. But also, as part of that, we can help ensure that these different application security scanning tools can run their scans and checks in an asynchronous manner. And then these findings can be automatically synchronized with your software development issue tracker or project management tool of choice. This is a generic framework that does not rely on any particular tool. So if we had to summarize some of the takeaways, so the first is that our number one takeaway is that please ensure that you are running these scans as part of your CI/CD pipeline rather than running it separately during the QA phase or expecting the dev teams to consistently run this. And your goal should always be to eliminate a lot of the manual application security triage process, all of the modern tools in the SDLC tool chain. Um, they provide REST API and develop an SDKs, and you can use that to even create custom integrations if there are no official integrations. But even in terms of a lot of the application security scanning tools, you will find that they have integrations with with the Jira software, since it's widely used by a lot of the dev team. They support technologies like webhooks, which make it very convenient to be able to make these tools to talk to each other and integrate them. If possible, you should also try to consolidate the number of application security scanning tools. One example of that is that uh, GitLab itself has a lot of different application security checks built in, like the static scan, the dynamic scans, the open source dependency scan, container scanning, and so on. A lot of these features are built into some of the tiers of the GitLab features. So you may want to also evaluate the advantages and disadvantages of using multiple application security scanning tools versus using some of the features provided by a tool like GitLab, which can help consolidate the number of tools. And overall, this can also help developers and dev teams minimize the context switch. And with the type of integration that we described, it can also help developers, for the most part, stay within their CI/CD pipeline and stay within their development backlog to like Jira software, and still get a lot of the feedback on potential security impacts based on the code changes that they are performing. So that was it in terms of the core content we had. Next, we will go into Q&A. I do see one question came in already, but please feel free to post any additional questions that you may have in the Q&A section, and I will try to address those. So the first question is if we run asynchronous scans, how can we ensure that the vulnerable code has not been deployed to environments? So this is a great question. So in terms of this particular issue, so the one idea is that you should be discovering a lot of these potential security issues early on in the development lifecycle, where the changes may have been deployed to a dev environment, but you would ideally, even for lengthier scans, ideally they would provide the feedback before you end up promoting these changes to production. The other is that, obviously we did simplify a few details in the framework that we described. But a lot of application security scanning tools also have two different modes of running the scans. One is running the scans in sort of a dev mode, where some of the thresholds can be more lenient and so on. And then you also have a scan that you can perform in the release mode, which is a more strict scan. So ideally, your CI/CD pipeline would be architected to ensure that your automated deployment step to production or a production-like environment can only run when you have a release scan that has been successfully performed. So by integrating those kinds of checks, this can help mitigate the issue where you may end up deploying some vulnerable code, especially to your upper environments like pre-production or production. And at most, those should only get deployed to lower environments. In fact, one of the features specifically with GitLab that I really like is that with GitLab, if you especially use their automated deployment integration, that also works really well with Kubernetes. GitLab can spin up a deployment environment for the branch or the merge request that the developer may have. And this way, even if you're running a lot of these dynamic scans, these can run even before the code gets merged into your dev branch. So that's one of the reasons why some of these checks go hand in hand with following some of the CI/CD and DevOps best practices in terms of how you deploy your application. So hope that answers the question. So we'll see if we have any other questions. I mean, one other question that we frequently get asked is, whether the framework that we described depends on particular application security scanning tools. And the answer is that it doesn't. Uh, I mean, there are some application security scanning tools that can certainly make it less, tedious to integrate it with your development backlog tool like Jira software. Um, but if you look in the Atlassian marketplace, especially for Jira software, you will find that a lot of the popular application security scanning tools have an official app for Jira software, which can automatically help you create some of these Jira issues based on the scanning thresholds, where you can define like the particular threshold of what the scanning tool may discover, and that can help automate some of this process. Also, another tip is that if you are using sort of code quality scanning tools, which may not be specific to security, but just general code quality. Some of the major tools like SonarQube also do certain security checks as part of code quality checks. So you can really utilize the features of a lot of these code quality tools apart from application security scanning tools to improve the application security health of your projects. Any other questions? We'll maybe give everyone another minute or two to post questions if they have any. And another question that we frequently do get is that, does this solution rely on a lot of these, DevOps and development lifecycle tools and application security tools being deployed in an on-premise environment or a cloud environment or a hybrid environment? And the answer is that it works for all of the above. So for example, in the customer case study, they were using mostly on-prem tools. So the GitLab instance and Jira software instance was deployed on their own infrastructure on-premise. But in terms of application security tools, they had a mix of SaaS-based application security scanning tools and self-hosted tools. So regardless of the hosting environment, as long as these tools can communicate with each other, and usually that's done over HTTPS-based REST API, you should be able to integrate a lot of these tools regardless of the hosting environment, including sort of hybrid hosting scenarios. All right, so it looks like we probably don't have any additional questions at this point. Please get in touch with us through our website, adtech.com. If you have any other questions that you can think of. And thank you everyone for joining us today. Hope you have a great rest of the day. Thank you.